Hi scientists! The topic of this lesson is incredible immiscibles. So immiscibles, that's maybe a word that we might be unfamiliar with. Well, would it help if I said to you that we're going to experiment with different liquids and we want to see if they will mix together? So that's my question. Do all liquids mix together? That's what we're about to find out. We're going to get right into activity 1, which is called Do All Liquids Mix Together? For this activity, each science explorer is going to need 2 tablespoons of water in a souffle cup, 2 tablespoons of oil in a souffle cup, and a few drops of red food coloring. So we're going to go ahead and start off with the water. Let's make some observations about this water. What does it look like? How does it move in the cup? We know it's a liquid, right? Is it thin? Is it thick? All kinds of words that we can use to describe it. The first thing that we're going to do is we're going to add some food coloring into this cup of water. What do you think is going to happen when we do that? Do you think the food coloring is going to just sit there? Do you think the food coloring is going to absorb into and change the color of the water? Just part of it? Go ahead and make some predictions. Okay. Watch what's happening. In a very short amount of time, this food coloring is mixing in with the water. It's changing color, and that color is mixing right in with the water. So now we no longer have clear water, right? We just have red water. We could say that water and food coloring are miscible, which means they mix easily. Next thing we're going to look at is the souffle cup that has the oil in it. Let's make some observations about this. Does it look the same as the water? Does it look different? Does it move or behave differently in the container? The next thing that we're going to do is we're going to add some of this colored water into the oil. Do you think they'll mix together? Okay, next step. You are going to test that hypothesis by pouring all of the water into your oil. And we'll talk about what happened. Take a look at that. What did happen? When we look from this angle, we can see that the water sank to the bottom and the oil is sitting on top. Did they mix together? No, they really didn't mix together well. And that's because of that word we talked about a little while ago. Oil and water are immiscible. Im is a prefix that means not. So if miscible means they mix easily, then immiscible is going to be the opposite. We say that liquids are immiscible if they don't mix together well. So even if we would stir or we would shake these two liquids up, they're really not going to combine. And there's a reason for this. What keeps them apart? It's their molecules. Oil molecules are considered nonpolar, which means the charges are spread evenly throughout them. Water molecules, on the other hand, are polar, which means they have a slightly negative end and a slightly positive end. Because of this, one negative end plus the other positive end of each molecule is going to make them stick together. When oil and water come together, the polar water molecules stick together, and they keep the nonpolar oil molecules from getting in between them. So that's why you see these liquids as layers that are not mixed together. Now, what do you think is going to happen if we take some more food coloring and we add a few drops to the top of the oil? I put in 3 drops. Can you see it? Where are they? Looks like they're sinking, but are they sinking all the way to the bottom? You can see that we still have those drops of food coloring in there. They didn't mix with the oil. Oil and water are immiscible. They're not going to mix. Instead, they'll separate into layers. The thing that's keeping them apart is their molecular structure. Water has molecules which are polar. Those polar molecules have a slightly negative charge on one end and a slightly positive charge on the other. The opposite charges of water molecules attract, causing the like molecules to stick together. Most other polar molecules are hydrophilic. Hydrophilic means water-loving. They're going to adhere to water easily. However, oil molecules are nonpolar. There's also a slight difference in the densities, which makes the oil float on top of the water. Oil is less dense than water. The denser something is, the more closely packed its molecules are, and the heavier it is. The food coloring formed droplets in the oil. It didn't mix because food coloring is immiscible in oil. They're not going to mix. The food coloring eventually will fall through the oil, and when it gets to the water on the bottom, we know it mixes with water, right? You see the red water. And if we look now, you can even see there's less droplets. So some of those droplets made it down to the water, and they've already mixed in. We know that food coloring mixes into the water because those two liquids are miscible. Let's test some other liquids to see if they are immiscible or not. So this activity, which is activity 2, is called immiscible or not. Here are the supplies that each science explorer will need. Specimen jar with a lid, 6 souffle cups, and they're going to be prepped ahead of time with the following liquids. So we want water with blue food coloring, half full. Water with red food coloring, half full. Whole milk, half full. Whole milk, half full. This is red oil lamp, half full. And this is corn syrup with blue food coloring, half full. So these will be prepped ahead of time so that science explorers don't know what liquids are in each one of these cups. So prep them. These are the materials, the water and the milk that we're going to need for our first experiment, and these are the ones we'll need for the second part of the experiment. All right, we're going to work with this first set of 3 souffle cups now, and let's make some observations before we go ahead and get started. Take a look at the liquids. We know they're liquids because look, they easily move around in the container. They're taking on the shape of the container that they're in. We could also observe that we have a red one, we have a white one, and we have a blue one. These are clear liquids, whereas this one, you can't see through it, can you? What do you think is going to happen when we mix all of these together? So first thing I'm going to do is pour the blue liquid into a 9-ounce cup. Next, we're going to add the white liquid to the same 9-ounce cup. So watch what happens. How did it change? I see it's still blue, but it's a lot lighter color blue. What's going to happen now if we add this red liquid to this light blue liquid? Look at that. It is now a purple liquid. So when we mix red, blue, and white together, we get a light purple color. Scientists are often going to repeat experiments just to make sure they get the same results twice. So we're actually going to try this again. So same thing, we have a red, we have a white and a blue liquid. And this time we're going to use the specimen jar. So let's pour the blue liquid into the specimen jar. What do you notice? Was it the same as our last blue liquid? Now look how slowly it's pouring, and you can see as it's landing in there, this is definitely a more viscous liquid, so we would say it's thicker than the first blue liquid that we worked with. Okay, we're gonna go in the same order here. So next we are gonna pour the white liquid into the blue liquid. What? Where did this one go? This time it didn't mix together and make a light blue. It is sitting on top of that blue liquid. Okay, I'm gonna keep the angle right here. We're gonna add the red liquid next. What do you think's gonna happen here? It lays right on top of the white liquid. Let's discuss these results. We said scientists are going to repeat their experiments to see if they get the same results twice. We certainly didn't. Why do you think it worked differently the second time around? If we look at the liquids in our first experiment, we see they combined together and they turned purple in color. The liquids in our second experiment didn't mix. They appear layered in red, white, and blue, kind of like a pattern. In the first experiment, we used milk and colored water. These liquids are miscible. Remember, that means that they mix together easily. In our second experiment, we used milk, which is in the middle here. We used oil, lamp oil, and we used colored corn syrup. The second group of liquids didn't mix together. Instead, they became layered in order of density. The density of these liquids is different. The corn syrup molecules are closer together, making it very thick and dense, so it goes to the bottom. The milk layered in the center, and the red oil, which is the least dense, floats on top. Time for activity 3. This is called red, white, and blue, so guess what? We are going to be using what we just made in our layered specimen jar from activity 2. So you need this, and you also need another souffle cup that's filled halfway with just plain water for all scientists. Let's make a hypothesis as to what we think is going to happen when we add this plain water to the layers of liquid that are already in our jar. Is it going to become a fourth layer, or is it going to mix with one of the layers that we already have in here? If we think it's going to mix, which liquid, the corn syrup, the milk, or the lamp oil, do you think is the same density as water? Okay, let's see what happens. What do you notice? I noticed our white layer, the milk layer, got bigger. Water and milk are the same density, so the water mixed into our layer of milk. But what do you think is going to happen if we put the lid on here and we shake these liquids in the jar? Are they going to stay separate layers, or are they going to mix together? Let's find out. We're going to go ahead and tighten the lid on. We don't want any of this liquid to escape. And we are going to shake, shake, shake. Take a look at it now. We're going to allow a little bit of time to pass, and then we're going to come back and we're going to look at it again. These liquids appeared to mix at first, and the color appeared to change. The milk probably changed in color a little because of the blue food coloring in the corn syrup. But once enough time passed, the liquid settled back into different layers based on their densities. All right, we have one activity left, and this is immiscible art. Before starting this activity, make sure the tables are covered because this one can definitely get really messy. Each Science Explorer is going to need 4 souffle cups with lids, 4 tablespoons of vegetable oil. So the first thing I'm going to do is add 1 tablespoon of vegetable oil to each one of the souffle cups. And then next, we need a teaspoon of food coloring in each one of these souffle cups on top of the oil. There's my oil. All right, a teaspoon. It's a lot of food coloring. Thus, the reason it could get super messy. See, look, I just squirted the table. Good thing it's covered. Helpful tip, what I did was I rinsed the teaspoon off between each one so the colors didn't mix. So now I'm going to go ahead and put the lid on top of each one. You want to make sure that they are secured tightly. Okay, and I'm also going to add cold water to the pan. You want just enough that it covers the bottom of your pan. Now, we're going to work kind of quickly because we know that oil and food coloring are miscible. So we're going to go ahead and shake each one of these up, but they're only going to stay mixed together for a short period of time because they're immiscible. So once they're shaken, we're going to take off the lids, and we have 4 pipettes. We're going to use the pipettes to put some of this color into the water. You can kind of experiment. You can see if you can get colors inside of other colors, however you want to do it. Okay, now grab a fork. I'm going to go ahead and swirl the colors in the tray. And then grab a piece of paper, so like a half sheet, have my initials on it. I'm gonna set it into the water. I'm gonna let it sit there for about 30 seconds. Okay, once it's been there for about 30 seconds, you're gonna go ahead and gently peel it out and let it dry. Go ahead and make one more. Whoa, that is awesome. Gently peel it out. Look at that. That is gorgeous. So we're able to create a unique swirled pattern on the paper, similar to a slab of marble. The reason this phenomenon occurred is due to the fact that oil and water are immiscible. They're not going to mix due to the difference in their molecular structure. Remember, polar molecules versus non-polar molecules. Food coloring is water-based, which is why it's immiscible in oil as well. Therefore, we can collect the oil surrounding the food coloring without picking up much water and print it on the paper. So can you answer the question from the beginning? Do all liquids mix together? They certainly do not. We now know that liquids that don't mix together are immiscible, and it allows us to do super cool things like this, making fancy art. Check that out. It also allows us to layer liquids in different ways so immiscible liquids do not mix.